Well, I came up with the idea for these rockets last semester sitting in my propulsion course, and I was really excited by what I saw on the board, but I was really hoping for a way to really make it tangible and to get my hands on it somehow and to apply it. And that has two major problems, one of which is safety when you're talking about rocket propulsion, and the other one is expense. I thought, what if I scaled these down to model rocketry? Because model rocketry has been around for a very long time and it's very safe. And it's also very affordable. For actually manufacturing these new parts, I heard that we had just gotten these 3D printers in, and I was very excited about that, and I just wanted to see exactly how far I could get combining model rocketry and 3D printing. This eventually evolved into these rockets, and these are a little different than the rockets that you see on the shelves. So the rockets you see on the shelves are usually made out of cardboard or other materials like that, and they're all usually one piece more or less. They're not very modular. This rocket instead comes assembled in large chunks. These chunks are still small enough so that you do a little bit of the assembly yourself, but it's very straightforward and there's no problems with precision or time. As soon as you screw these things together, just like this, after a few more parts, it's ready to go. Also, because of this modularity, if you break a part, you can also just disassemble it, take out the part, and swap it in for a new one. I've taken them to Mayfield High School, where I've tried to enhance science education with them with a couple classes where I've had 94 students in total, where I've tried to teach them basic parts of physics and then other things related to science, like the scientific method, with these model rockets. Here at NMSU, my propulsion professor has expressed interest in perhaps incorporating some of these things into his course next fall. So that would be taking some of the things that I've been doing and some of the work which I've been thinking about and actually using it to direct a student project where we actually would take all those really cool propulsion ideas and theories and pull them off the board and do an actual applied project. Rocketry is very important because it makes science and engineering a lot more hands-on. So this is a way where we can do it easily and affordably, and we can get people more interested in these subjects, and we can show them that it's not just things in a book, it's not just things on the board, it's real life things that they can do, that they can have a lot of fun with, that are very exciting. So it gets people excited, it helps them with all sorts of little real world problems that you wouldn't necessarily get on a chalkboard, like group work, teamwork, communication, little things that go wrong in real life, where sometimes you'll try to launch the rockets and they won't go. Just little things that you encounter in the real world all the time, but which just aren't that present in a classroom.